Welcome to multiple choice question 16 of the 2015 Mathematical Methods Exam 2. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. And now just before I move on, I'd like to point out that the use of a CAS calculator was not appropriate for this question, as there was no way of entering into it and getting the required output out of a CAS calculator. For question 16 we have let f of x equal ax to the power of m and g of x equal bx to the power of n, where a, b, m and n are all positive integers. And we know that the domain of f is equal to the domain of g, which is equal to all real numbers. And if f dash of x is an antiderivative of g of x, then which of the following must be true? So we're going to start by unpacking the highlighted statement that we know that f dash of x, the derivative of f, is equal to the antiderivative of g of x, or equal to an antiderivative of g of x. So therefore, if we calculate the derivative of f of x, we would have m times ax to the power of m subtract 1. And if we were to calculate an antiderivative of g, that would be bx to the power of n, and we add 1 to the power before dividing by the new power. And now we know that both of these terms are polynomial terms, and for two polynomial terms to be equal, their coefficients must be equal and their powers must be equal. So therefore we could say that m minus 1 must equal n plus 1, and we also know that a times m must equal b divided by n plus 1, so that's the coefficients being equal to each other. Now, working with the powers being equal to each other, we could write that m subtract n is equal to 2, rearranging that, which looks very similar to e, but it's not quite correct, so we can cross that out. So that means that one of the other four options must be correct, and to find out which one's correct, we're going to work with the coefficients being equal to each other. So we can rearrange this as being m times n plus 1 is equal to b divided by a. So from there we know that m is an integer and n plus 1 is also an integer. So we have two integers multiplying each other, which will give another integer, which is equal to b divided by a. So therefore b divided by a is an integer, making D the correct statement. So from the examiner's report we can see that only 22% of students got this question correct, and that based on how the results were distributed, students were generally guessing at which one was correct. The examiner's report details how they approached this question, which was similar to what we saw on the previous slide. They also gave an example if m equals 3, what the ratio of b on a would equal, and in that case it would equal 6.